may see in other classes.
Now I'm understanding this stuff a lot easier when it's taught from physics background than when I took chemistry.
Yeah.
That makes more sense.
You've come to the dark side.
I never liked chemistry.
No, I never liked chemistry. You either like chemistry or you like physics, but the twain shall never meet.
No, I like
That's not afraid.
chemistry and physics.
Well, physics is kind of philosophical, as we found.
I like physics more than chemistry and stuff. Chemistry hate. Like, I don't like chemistry, but why do you have to hate?
You know, I don't mind chemistry. What I don't like about chemistry was the teachers that required you to memorize the periodic table.
Yeah, that's kind of dicey.
I say F that. Any class where you have to memorize periodic table. I mean, we have a textbook. We have textbooks for a reason. When are you going to be lost in the desert and need to know the number of electrons in the fourth shell of beryllium?
You need to know the atomic mass, not the electrons. That's a fool's game.
Well, who needs to know the atomic mass of beryllium when you're stranded on a desert island? Anytime you need to know it, you have a book or you have Google. I say, memorizing this, that's the part I didn't like about chemistry. I liked the class where they took all the chemicals and they poured them on the desk and then they lit it on fire. That was fantastic.
They do that once.
Yeah, that was,
one exciting
Whole
thing
year
for
they do that
chemistry.
one time.
yeah. Or when we distilled alcohol and then got to burn that. That was pretty cool.
All the cool things
Magnesium and water.
revolve around fire.
That was pretty cool. Okay, the worst lab ever. Here is this compound that looks like water. Figure out what it is. By the way, don't drink it. It will kill you. That's what I don't like. I'm like, you know what? I'm done. I'm done with the things that can kill me that look like water. Yeah.
Wait, will kill you. This is
Stick your
important.
finger in and taste it.
I think I kind of already touched on this, but just to reiterate, N is associated with the energy, the shell. L is associated with the shape of the cloud, so you can be at the N equals 2 shell, but you can have 2 or 3 different configurations of the cloud. And then M sub L is associated with the magnetic moment of the electrons. That's just its orientation relative to the universe. So why do we love the hydrogen atom so much? We love the hydrogen atom so much because the Bohr model is very easy to understand, but the Bohr model doesn't work past the hydrogen atom. When you introduce more than just one electron, the Bohr model breaks down. It's not complicated enough. As we saw, in reality, you have these probability distributions. You don't have particles orbiting in these nice orbits. So that's why we're always talking about single electron atoms. You're going to solve problems that are, imagine this theoretical single electron atom, because it's boring to solve every problem about hydrogen. But that's why we're stuck with hydrogen, because if you want to deal with anything with more electrons than hydrogen, you have to take quantum mechanics, which we're not teaching in here. So this lecture is not at all quantum mechanics, actually. It's pre-quantum, I guess, pre-quantum mechanics. So I said the ground state energy of hydrogen is minus 13.6 eV. And so the energy of an electron that's above that level is easily calculatable with this equation. So that's only for hydrogen. That 13.6 is specific to hydrogen. If they give you some other imagined one electron atom, then they'll tell you its ground state energy is something other than this value, and you can just change that numerator to whatever that new value is. The same equation will work just with the new value for that imagined.
For the ground state.
For the ground state, yeah. So you can call the ground state energy E sub 1 using the same notation. Ground state would be N equals 1 So that would be E sub 1 for hydrogen. So that might be some other way they give you the ground state for some imagined single electron atom. All right, another one you can review at home is example 39.6. So n could increase all the way up to infinity, but as n increases, this equation goes to 0. So everything inside this well has negative energies. Once you escape the well, then you get positive energies. And just to sort of lead us into our discussion about particle physics that you don't really have to use for any equations, we also have a fourth quantum number I haven't mentioned. Sometimes, well, if we're simplifying things, we don't really need to mention it, but you may have heard of electron spin, and you can have spin up or spin down, and so that's another way you can describe your electron is with electron spin. I think I've talked about everything else. So problem 3926 is the last problem we're going to do tonight before we get to chapter 44, which is just for your enjoyment. Okay, so problem 3926, a hydrogen atom initially in the ground level absorbs a photon, which excites it to the n equals 4 level. Determine the wavelength and frequency of that photon that helped that electron jump up. So spend some time on that. I'll turn off the video and we can talk about it if you guys get stumped.